Yeah, hello guys. I hope everybody is fine. So today I'm gonna talk about. First of all, let me introduce myself to you. I am a computer science and engineering student from SRMAP University in India, and I have a small project that I'm going to present to you guys today. So welcome to my YouTube channel. This is my first YouTube channel, so I am a little bit stressed. So first of all, as a student, I'm going to say if I'm making any mistakes, please reach out to me and try to correct if there is any mistakes that I made in this project particularly. I'm just learning. And so welcome. Let's go. Let's start. So this is the computation part. It is based upon a SBERT algorithm. What is SBERT algorithm actually? The SBERT full form is like, the full form is about the SBERT is an algorithm, a deep learning model used for internet like information retrieval system. So what is the use of it? This model is basically efficient to retrieve the most significant word, like most relative word in terms of query. So based upon the query in the based upon the query in a particular document. So what is it? The full form of it? It is sentence by directional encoded representation from the transformer from the transformer. The SBERT is modification of BERT. So and a deep learning model developed by Google for understanding the meaning of the text. While BERT can understand language context, it is computationally expensive to compare large numbers of sentences. SBERT solves this by converting sentences into fixed length numerical vector embedding. So the embedding is just about converting into the numerical vectors. So embedding that captures semantic meanings. This embedding allows fast comparison between sentence using similarity measures like cosine similarity. Cosine similarity. This is very important for measuring like for taking the the right decision, because it's gonna compete between the sentences or between the words, or in other words, I can say between the tokens. So when the model will take this while taking the sentences, the words, and compare between them, compute them, then pass into certain model that we are going to see feed forward neural network. This feed forward neural network, after passing the output of the comparison from SBERT, it will process this to the output and then produce the question similarity. So we're gonna say we will go to Medium, my Medium account, and I'm gonna say here it is. So this is my Medium account here. Yeah, it is like the theoretical understanding, that's the title, understanding the chess with Sentence-BERT. So which is the sentence bidirectional encoding, restriction from the transformers. So this is the full form, and the content is search the revolutionizing information retrieval by understanding the meaning behind user queries. So not just matching keyword, but SBERT is a powerful tool that enables such contextual search, providing more accurate and relevant result. You're gonna see, you will understand this content part. The tradition here is the traditional part compared to semantical search. So this is the real life problems. What is the Sentence-BERT? And we're gonna see what we have done in the top of the slide here, and we can also we can just try to make you understand through this diagram, because this diagram will explain you everything. Also, it is easy to understand. That's why I've taken this diagram to explain you. So it is based on the model BERTs, like it is taking two sentences. It takes two sentences, complete them, and pass the output to the feed forward models here. This sentence A and B will be passing to the model. A model will complete them, then pass through the feed-forward neural network. So this one also will process them and produce the constant similarity that we're gonna see in the numerical example downstairs here. So we got just these are just the explanations, and here is numerical candidate one, candidate two. Here is the query vector Q. So we're gonna see, you can clearly see here, this is the query that we have. We're gonna take this query one and query two, and candidate one, candidate two, C1, C2. The outcome are here. So what we're gonna see, we will proceed with the question similarity. So after computing, you're gonna get this, you're gonna get 0. This and 0.505, which is showing that and the importance of the most relevant document, the most relevant sentence or word is the candidate one that is similarly closer to the query 0.984. It is going to be 0.984 compared to the query candidate two. So this is the beauty behind this model. It is very important and help you to understand and quickly save your time to retrieve the most relevant informations in this system. So after that, we are going to see, I will show you the Google Colab script that I'm gonna implement the code using Python code. I just firstly import the necessary libraries here. Then I will load the dataset. Here are the simple small dataset that I loaded here. So after that, we are going to pass the model and encoding. So model name and encoding, we have we are using this model, then encode the model again, then we will be the first index. This is also another model that algorithm that we use it, and BM25 along with BM25's baseline here. Then we search the function and evaluate them. Then after we combine the result in a table, so there we're gonna see the output here. So you can clearly see the output. These are just the confirming that the library have been loaded successfully. There's no any issue with loading the dataset and importing the libraries. So here is the our where we are interested about. Here is the our output. I will say, well, we computed the output with this matrix here, 1, 1, and 0.42, 0.5. Then the query example is also done with along the result of the combined results. Thank you, everybody. Welcome to my channel and see you to the next lecture. I hope, please, if you are getting any query, please help me to understand properly. And I am really glad to be here as my first live streaming. And if there is any suggestion, or if you knows very well, if you are a teacher or a professor, you can give me any suggestion to learn more about. I eager to learn more about these models, especially about information retrieval. So thank you everybody for joining me, or you can leave a like or comment, or you can reach out to me. I will just provide my email down there in my bios, and you can contact me with along with my phone number. Thank you. Bye bye.